All right, welcome to another video. This is probability part 2, video 1. There'll be 3 parts or 3 videos to this part. We're going to look at theoretical probability, empirical probability, and probability and permutations. Probabilities are assigned values from 0 to 1. The closer the probability of a given event is to 1, the more likely it is that the event will occur. The closer that the probability of a given event is to 0, the less likely that the event will occur. Theoretical probability. We're going to familiarize ourselves with some terms. Those are experiment, which is any occurrence for which the outcome is uncertain. Sample space, which is the set of all possible outcomes of an experiment. We usually use an S for that. Event, which is denoted by E and represents any subset of a sample space. And the sum of the theoretical probabilities of all possible outcomes is 1. Let's look at how we compute theoretical probability. If an event has n of E equally likely outcomes, and its sample space S has n of S equally likely outcomes, the theoretical probability of event E, denoted by P of E, is, we'll take P of E equals the number of outcomes in event E, which is n of E, divided by the total number of possible outcomes, which is n of S. Let's take a look at a couple of examples. I encourage you to pause the video now and try this one on your own. A die is rolled once. Find the probability of rolling a 1, a 7, and an odd number. Those are going to be 3 different probabilities. So pause the video and try it. We're talking here about a fair die, which has the numbers 1 through 6 written on each side. So a 1, a 2, a 3, a 4, a 5, a 6. Those are the only numbers on there. So the probability of rolling a 1, just to remind you about the definition of probability, number of ways to roll a 1 divided by the total possible outcomes. So there's only one number 1 that appears in the die, so the probability is 1 out of a possible 6. Let's take a look at part B. So in rolling a 7, it's how many ways we can roll a 7. I'll fix that right quick. Oop. And out of the total possible outcomes, well, there are no 7s on this die. So the probability of rolling a 7 is actually 0 out of 6, which divides to 0. Also known as an impossibility. For an odd number, we're looking at the probability of rolling an odd number is the number of ways to roll an odd number divided by the total possible outcomes. And so we have the numbers 1, 3, and 5 on our die. And so that means that we have 3 odd numbers out of a total of 6. This can also be reduced to 1/2. Example 2. Again, I'm going to read it, you're going to try to pause it and try the example. You're dealt 1 card from a standard 52 card deck. Find the probability of being dealt A queen, B, a heart. So first, let's familiarize ourselves with the cards. So we have a standard deck of cards, there's 52 here. You have 4 suits, that's spades, hearts, diamonds, and clubs. You have your number cards, and you have your face cards, jack, queen, and king. To find the probability of being dealt a queen, we should check how many queens there are. Well, there are 4 queens. If you don't believe me, check right here. 1, 2, 3, and 4. And a total of 52 cards. So we have 4 out of 52, which reduces to 1 out of 13. Okay, so you have probability of getting 13 cards that one of them will be a queen. What's the probability of getting a card with a heart on it? What the hearts have, there are 13 of them. So if you count these, right, we get 13. Out of a total, again, of 52. Think about it for a second, what does that reduce to? And that reduces to 1 out of 4. That's an even better chance that you'll get a heart than you'll get a queen. So probability is 1 out of 4 rather than 1 out of 13. So let's take a look at what the difference is between empirical probability and theoretical probability. So we already covered theoretical. Empirical, another name for this is experimental. applies to situations in which we observe how frequently an event occurs. So when we compute empirical probability, we're going to look at the number of times we observed E occurring, this event, over the total number of observed occurrences. So let's say that you were flipping a coin 100 times and you didn't get 50 heads and 50 tails. You got 25 heads and 75 tails. In that case, the probability of a head would be 25 out of 100, or 1/4, not a half. Here you can see the difference between empirical and theoretical probability. Here we have an example. So in this example, it looks like there was a questionnaire that asked 242 people whether they asked for their gender, binary gender. They asked if they were married, never married, divorced, or widowed. And so we can ask lots of questions about this. One question we can ask is, what is the probability that a person selected is a female? So the probability of that is going to be the number of ways you can select a female. So we look at this total column here, 124, out of the total number of people that were questioned, so 242. These are, by the way, in millions. The probability of selecting a female is the observed number of females divided by the total number of adults. When we go ahead and divide those, 124 over 242, we get 0.51. Notice that that's not exactly half of the population that was questioned, but it's pretty close. And that means we probably did a good job of selecting a wide range of people to ask. All right, let's take a look at an example that's a little bit different. So let's say that we were analyzing jokes and that we had 6 jokes about books by Groucho Marx, Richard Pryor, Robin Williams, Chris Rock, Jerry Seinfeld, and Phyllis Diller. And they're written each on one of 6 cards. The cards are placed in a hat and drawn one at a time. So what's the probability that a man's joke will be delivered first and a woman's joke will be delivered last? Okay, so pause the video and try it. First, we need to look at the number of permutations that a man's joke was first and a woman's joke was last. It's often easier to do the denominator first, which is the total number of possible permutations. So for the first joke delivered, we have 6 choices. There are 6 comedians. In the second joke, we assume that we've already picked one. We now have 5. The third joke, 4, and so on, right? 2, and then for the 6th joke, we have 1 choice remaining. This gives us a total of 720 permutations. So here we're using either 6 factorial or we're saying 6p6. All right, so that gives us our denominator. Now let's see how we're going to calculate the numerator. For this, we're going to use the fundamental counting principle to see how many permutations we have with a man's joke first and a woman's joke last. So for the first joke that's delivered, it could be a joke by any of the 5 men. So there are 5 choices for that first joke delivered. For the 6th joke, well, there's only 1 woman in this group, so we only have 1 choice here. Okay, so what we have is we have 5 times 4 times 3 times 2 times 1 times the 1 choice for that 6th joke, since there's only 1 woman to choose from. That gives us 120 for the number of ways this can happen out of the total possible outcomes, which is the 720, which gives us a probability of 1 out of 6. I encourage you to pause the video and think about another question that you could ask for the same scenario. All right, on to video 2.